Well, hello friends. Today we're going to work on the browser again, and I'm going to implement hover pseudoclasses. So let's make a little test page for that. So basically what I want to achieve is when you hover over a link, then it can turn into a different color, right? Because I remember when that first came out in I think it was IE 3 or IE 4, and it was so cool to see the links change color when you hovered them. And I remember Netscape didn't do that originally, so it just felt like IE is so awesome because the links change color. And those were good times, right? So let's recreate some of those good times by making a little test page. Home and on, hover. So just start by making a little test page like we always do. I'm even going to give it a title, hover test. And let's make a little style sheet for this so that we can actually, we don't need to say type, but a hover, that's easy enough. Color red, maybe, yeah, that's cool. And then we'll just make a link, ahref. I don't know. How about nothing? I don't know. It's not about where the link goes, right? It's about this. Actually, let's just link to ourselves. Isn't that nice? This is a link. Okay. And this looks really messy, but I'm just not going to care. And then we'll also edit the welcome page to have a link to it. Just because that's nice. So we can click our way to it. Okay, so let's see what this looks like right now. Because yesterday I added parsing of pseudoclasses, which is, it's not complicated, but I just wanted to get that out of the way because I find that like trying to parse stuff while recording it's like, I don't know, I have a hard time making that interesting, I guess. But it is really, really simple. Pseudo class, I'll show you how it looks. So in the selector component class, a selector component is now a type, a pseudo class, and a relationship to the selector component on its left, which you would be familiar with if you watched my video on descendant selectors and child combinators that I did a while ago. So pseudoclass here is new. So a selector component can now have an optional pseudoclass, and by default it's none, but we can parse out if it's :link or :hover. And there are other ones like active and any link and focus and whatever, but like we're only going to care about hover right now. And in the parser, I guess I can show you that. When we parse a selector component, then if after the main component there is a colon, then we just take whatever comes after the colon and interpret that as the name of a pseudo class. So anyways, but this isn't about that. This is about actually using this information to implement some kind of hover effect. So first, let me show you what this would look like right now. So it thinks that it's always hovering. Obviously, that's not right. So if we go and look at the selector engine, we can see here that when we are evaluating if a selector component matches an element, we don't look at the pseudo class. So in this case of this test page, that hover selector is always going to be a match because we don't look at the pseudo class. So let's do that here. So let's just say switch component pseudo class, and if it's none, then that's fine. Then we can just break, because then we should evaluate the rest of the selector component. But if it is a link, I don't want to implement that one right now, so I'm just going to say assert not reached, and then I can get here at some point later. And then for hover, What we want to do is maybe let's make a separate function for this. So let's say if not matches hover pseudo, or how do we want to evaluate this? If not matches hover pseudo class element, then we'll return false, because then it's not a match. And then let's make one of these. So it matches the hover pseudo class if we are hovering over this element right now. So the DOM document knows which node is currently being hovered. So that's stored here in mHovered node. But that might very well be a text node that's inside of an element. And I guess we should still consider it hovered at that point. So maybe, I don't remember exactly how this works in other engines, so I'm just going to approach it from common sense here. So I guess the obvious way to do this is that if the thing that we're checking the selector against is an ancestor of the currently hovered node, then we would consider the ancestor to also be hovered. I feel like that makes sense. So let's do that. So if element is the hovered node, then it does match it. But also if element is an ancestor of the hovered node, so return element is ancestor of hovered node, and and we want to check if there is a hovered node. Okay, right. So if there is no hovered node, return false, because then we definitely are not hovering anything. We're not hovering this element because there is no hovered node. Yeah. Let's see, maybe we should write this out. Hovered node is, because it's so repetitive, so I don't like that. Okay, there we go. It's slightly nicer. Okay. So now when we evaluate the selector component and it has a hover pseudo class, then it has to match. This function has to return true, or we'll say that the selector does not match. This could be static, I guess. Yeah. Okay. So, this could be static as well. I'm just noticing stuff. But actually, let me leave those alone right now. I don't want to mess with unrelated stuff. So this looks good. So let's try it out. Right. So the problem now, obviously, is that just because I hover something, it doesn't mean that we rerun the selector engine. So how are we going to do that? I guess an easy thing that we could do is when the hovered node changes, then we could recalculate style, or we could do a style invalidation for the node and then see if anything changes. we don't have any mechanisms for this right now, so we're gonna have to invent something. It'll be kind of crappy for sure because we're just starting out, but basically we want to react to the hovered node changing. So we have set hovered, where is that? Set hovered somewhere in document. Okay, it's just a dumb setter. So we're gonna move this out of line. And let me make it a bit bigger actually. And maybe I'll even maximize it because some people like that. Okay, so document set hovered node. mnode is node, right? If mnode is already node, then that's a no op. Okay. Oh, it's hovered node. And then both the old, previously hovered node and the new hovered node, they both need to be invalidated. So let's say that we just do a hardcore invalidation. We invalidate the style, which will cause us to recompute the style and relay out the whole document. Maybe that's actually good enough for a first version here, but let's see. That is actually really cool. Okay, so that just worked right away. Kind of happy actually. That's really neat. Let's I kind of almost wish that the default style sheet would have this behavior, because it's just such an awesome behavior. And you know what? Since we control the default style, I'm just going to put that in there. Color red, because that's so freaking cool. And I think we'll just do that. I think the first time I ever saw this effect was on Microsoft.com back in, I don't know, 97 or 98 or something like that. And they had underline turned off by default, and then the underline would show up when you hovered, and it was just so cool. But I don't want to do quite that to the default style, because I do like having the underline always there. And I think they also had it become bold. I wish I could see exactly what it looked like, but actually maybe we can go to the Internet Archive and find it. Hit me with some really old Microsoft, please. A lot of suggestions there. I'm probably gonna not do the style invalidation actually, now that I realize that we can just restyle the whole page, because style invalidation is like a whole other science of itself, of its own, and I'm gonna want to put some more data structures in place before I can do something really meaningful with that anyway. Oh well, I forgot how super slow the Internet Archive is. So let's just try out the default style sheet and see what it looks like. Oh, look at that! How cool is that? Let's go to serenityos.org. Oh yeah. Okay, so we have a big page here. Oh, did it crash? Yeah, sometimes things crash. The browser is a little bit fragile. Like, it works best if you don't move the mouse while it's loading something big. And sometimes the DNS lookup just fails, and then the system crashes. And you know, there are a lot of things to fix, but we'll fix them, you know, one at a time. So let's see how this goes. It's a little bit sluggish, but it does work, and it even blinks here. Oh, actually, I guess that whenever I'm moving the mouse, maybe it's changing the hovered node, and it does relayout of the whole page because of that. Yeah. And I got real sick of my shit here and crashed. Well, I'm still gonna be happy with it the way that it is, and but maybe we could do better. Maybe we could just do a little bit better. So what would we actually need to do? So if we invalidate the style of the whole document, yeah, but what if we just invalidate the node? Then we would have to invalidate the node and all of its ancestors, and then recompute the style for them, and then take that style and see if it changes the layout in any way. And if so, relayout. Otherwise, not relayout, but if it changes the look in any way, then we have to repaint. Well, let's look at it. So let's see, node. Where's invalidate style at the moment? It's on document, I guess. Yeah, on document. And what it does is it just throws away the layout root and invalidates the layout. So then it rebuilds everything. But what if we just, on node, have something like void and actually on document, let me rename invalidate style because I don't like that name anymore. Actually, let's approach this in a few batches. So let's first commit what we have here. So let's see. It's just a simple hover effect. And then we invalidate the style of the whole document when the hover node changes. Okay. And blah, 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 blah. Yeah. Let's commit this. Oh, and let's add that hover test. Additional. Implement basic hover pseudo class support. This is currently very aggressive. Whenever the document hovered node changes, we invalidate all style and do a full relayout. It does look cool though. It does look cool. And oh shit, I forgot to mention. Does look cool though. So cool that I'm making it part of default. I'm adding it to the default. Okay, so that's not the default style sheet. Okay, we're good. Now let's rename document validate style to rename it to update style, and we'll invalidate layout. We'll rename that to update layout because these are not invalidating; they are updating. They're doing like the synchronous work of updating. So let's call them what they do. Good. So HTML rename document invalidate style layout to update. Yeah. Okay. And oh, actually, this thing we should rename on invalidate to on layout updated. On layout updated. Yeah. And okay, that's good. So in node, let's now add, so the DOM node should now have an invalidate style function. And what we'll do with that is we will walk our ancestor chain. Ancestor plus, no, not plus plus, what am I doing? Parent. And then if ancestor is an element, then, oh wait, no, if is element ancestor. To element ancestor. What do we want to do? We want to recompute the style. How do we do that? So we'll do we'll call something like recompute style. So that's what this will do. We'll just walk all of the ancestors of any node, and then for each element ancestor, because only elements can have style, so that's important. Text nodes cannot have style, so we can skip over those. That's what we're doing here. So we'll call recompute style on each element ancestor, and then what's that gonna do? Element recompute style. So currently, when we want to compute the style for the first time, like the normal way that we do it as part of creating the layout tree. And that's driven by document layout. So when document layout is called, if there is no layout root, so there is no layout tree that corresponds to this DOM tree, then we construct one. And the layout tree function will basically recursively walk the whole DOM tree and tell each DOM node, hey, create a layout node for yourself and give it to me. And then it builds the tree based on what each node thinks that his representation should be in the layout tree. So, right, so this actually is going to be recursively called on every DOM node. So the first thing that every DOM node will do is create his own layout node, and then if it has any children, then it will walk its children, and this is where the recursion happens, right? Because then we create the layout tree for each child and so on. And where do we compute the style? Create layout node. Let's look at what we do for element create layout node. Aha. Here is where we resolve the style for each element. So when we tell an element to create the layout node for itself, the first thing it does is ask the provided style resolver to resolve style for itself, and also passing in its parent style. Let's see how we can do this. So I feel like we can probably cheat and get, I'm just thinking about like, where do we get the parent style from if we don't have it? But the style properties end up being stored on the layout node. Because you can see here, like we hand over the style, we hand it to the layout node that we construct. So I think we can grab the parent style from the parent elements layout node, basically. That should work in most cases. I'm sure that there are some situations where that's not correct. Maybe if you're inside of an anonymous block or something, but I'm just not going to care about that right now because I just want to see if we can make some basic recompute style on an individual element. So let's see, auto, we'll do a, we want the style resolver. We can get that document. Oh, we need to include document.h. Okay, so let's get the style resolver, and we'll say resolve style. This, and then we need the parent style. So here we're gonna cheat, and we're gonna say parent, or hold on, let's see, how do we get the parent style? If there is no parent, then that's weird because then we're not in the tree, because walking the ancestor chain should always take you to the document root. So if an element cannot be the root of a document. The root of a document is always a document node. So if an element does not have a parent, that means that it's not currently in a document. And if it's not in a document, we don't care about computing style for it, so we can just not do anything here. And in fact, we could assert that we don't end up here because we should not be trying to recompute style on an unparented element. So let's see. I totally forgot what I wanted to do. Oh yeah, compute the parent style, or get the parent style. So the parent style is, let's see, if parent is document. Oh, well, it doesn't matter. We just grab the layout node. So parent render, not a parent layout node is parent layout node. We'll assert that the parent has a layout node. And then this is probably going to bite me in some situation that I'm not thinking of right now, but that's why I put the assertion, because then I'll have to figure it out when I hit it. Okay, and then here we can just say parent layout node style, like that. Okay, now we're passing it the parent style. So this should give us the appropriate style properties object for this element. And then let's see. And then what do we do? Then we take it and I guess what we really want to do is like we want to compare our current style with the new style and see if the diff between them, like if that warrants like a repaint or a relayout or what. So that's what we want to figure out. So let's see. Let's make a little helper for that, I guess. We'll call it like, let's have an enum style difference, or let's see, none. And it can be, it needs repaint, and maybe needs relayout. Style difference. Style difference is like not the right word here. Style change consequence. No. Okay. Let's see. And then let's have a style change consequence. Compute style change consequence. Style difference was a much nicer word to say though, so I'm just gonna call it that anyway, because it just feels nicer, even if it's maybe not the correctest thing. Okay, and then we'll take as an input, we'll take style properties, old style, and const style properties, new style. Okay, so first thing is first. If old style is equal to new style, return style difference none. And of course, there's no equality operator for this thing, so I thought that was going to be easy, but okay, fine. We can implement that actually. Bool operator. And let's also do this one as a function of the other. It's going to be nice to get that spaceship operator in the next C++ standard, so you don't have to do this type of stuff. Let's see. This equals other. Okay, and now let's implement that guy. So okay, if other dot, or no, what kind of members does this thing have anyway? I forget. As a font, but we can ignore the font because the font is just a function of properties. So we just have to compare these hash maps. If m property values size is not other m property values size, return false. Okay, and then let's see for auto, or no, let's do, how do we do this? For auto it in m property values, and then auto jit is other m property values, because we can't just compare them because they contain like pointers, and these values might be like identical even though they're not identical pointers. And style value does not have a comparison operator, so this is kind of a hassle actually. Actually, the style values should have comparison operators. But for now, I'm just going to be a bit lazy here and take a shortcut, and we'll do it key if jit is other m property values, and then we'll return false because that key did not occur in the other. Okay, and then auto my value, it value, my value, their value, or other value, jit value. Oh, wait, is that not right? JT. Okay. If my value type is not other value type, return false. Oh, I can't do that either. I have to do. Oh, hold on. Let me star that. There we go. Okay, and then otherwise we'll say if my value, we'll just compare their string serialization, other value to string, return false. And if we manage to go through the whole map and everything matches an existing entry in the other one's map, well then that's true. Then these style properties objects are equivalent. Okay, that was boring. Let's see. So now we want to compute if it needs repaint. So I'm thinking that like these are like in order of intensity or whatever, because like if there's no difference, then this does not require us to do anything. But if we need to repaint, we have to at least redraw the contents of the HTML view. And if it needs a relayout, we also need to potentially like move everything around. So this is like the heaviest situation because this one includes this one. And hopefully we would be able to find that we only need to repaint. So let's see. What do we want to do? We want to like, I mean, I'm not going to implement like the whole thing right now, but let's do a targeted thing here. And if old style dot, let's iterate the properties. And let's say style difference diff is style difference none old style for each property. Or maybe we can iterate over the new style. Diff. Alright, let's do it that way. Name auto value. Wait, how does this look anyway? What are we getting for each property? We get the CSS property ID and the property value. Okay, so let's say that if property ID is CSS property ID color, let's see, if value, oh, we want to look at the other one's value here. So I want to do that. I want to look it up in the other one. So new style. We're iterating over new style, so we look it up in the old style. This makes me wish that this thing would not be like a hash map, but it would have like getters for everything, because then I could just write out like a long function that compares the result of each getter. But right now it's a hash map, so we have to deal with it. Although maybe I can pretend that it has that API, because it has an API that allows me to query an individual property. So I could say if new style dot color or fallback CSS property ID color, and then I just have to give the document. So I have to pass that in somewhere. Didn't remember that. Okay. Auto diff is compute style difference. Okay, so the old style is my current layout node's style. We'll assert that we have a layout node. And then the new style is what we just computed there. And then we want to pass in the document. Okay, so that's the diff, style diff. Or just a diff, okay. Okay. So let's go back up here and maybe we can do this in a simple way. Color, let's just say black is the fallback. If this is equal to the same thing called on the old style, if they're not equal, then we at least need to repaint. Okay, so let's say diff and style difference needs repaint. This is actually not, this enum is not working out the way I hoped immediately, so let's just say needs repaint. And we'll do needs relayout. If needs relayout, style difference needs relayout. Otherwise, style difference none. Okay. So, if the color property is different, then we set needs repaint is true. And we can do the same for like background color. So this should be like, this is going to be like a really big and messy function. So let's just do let's just do these two actually. But obviously there are, you can imagine that every property would have some sort of consequence if it changes. But I'm not going to do these in the video, but like, let's put these two, color and background color. So if any of those change, then we'll determine that we need a repaint. This function will return needs repaint. And then here, if diff is style difference none, then we'll just return, because then this is a no-op. And otherwise, if diff is style difference needs relayout, let's assert not reached, because I don't want to implement that mode right now. And then if diff is style difference needs repaint, then we'll do set layout node set needs display. Yeah, because what that will do is it will call set needs display on the frame, which will invalidate this element's rect. Whew. Okay, so I think we have a basic algorithm here for oh wait, hold on. I need to actually, what am I forgetting? I need to actually save the style to the layout node. So if it does need a repaint, here I want to store the new computed style on the layout node. So layout node set style new style, I guess. It is mutable, but there's no such thing as set style, right? So we just have to add a set style function. So there's layout node with style, which is a subclass of layout node, because not all layout nodes have style. So if you have style, then you inherit from layout node with style. So I'll just put that here. Set style, const style properties, or actually, let me, or no, it can be like this, because we will take shared ownership of it. And style is style. That's cool. And here, layout node returns a layout node. It does not return a layout node with style, but in element, we could actually make it layout node. We can make an overload that returns a layout node with style, because elements always have style. But not all nodes have style, but elements always do. So style. Can make two variants of that, and class layout node with style. And I don't want to include that header here, so I'm just gonna instead in layout node at h, I'm just gonna do it at the end. It's a little bit ugly to put like these implementations of another classes stuff in the header, but it's an ugliness of C++ that you have to deal with, like cyclic header dependencies. It's really irritating. And oh shit! And I still need the definition of element here. I thought I had that. Oh well, I don't. Then maybe I can just get the definition of layout node in element.h. Maybe I can just do that. Then that would allow me to do layout node like that. Okay. We call set style, and then we do a repaint. And then when we paint that element, it should pick up the new style that we set. I feel like everything will fit together. Maybe it'll just crash spectacularly. Okay, so far so good. But I definitely didn't even call the new API yet, so I shouldn't be too excited at all. So here we call update style, but now we want to instead if mHovered node validate style. And we want to deal with previously hovered node as well. So there we go. Okay, well, something happens. We definitely are not doing the full thing correctly. But, oh, well, what am I going to learn by doing that again? So let's see. What do we want to print out to learn more about this? I guess we can say every time we invalidate the style for something. Debug invalidating style. Tag name, and maybe our pointer, something like that. Yeah, that would show us something. So, okay, so no amount of repainting causes the style to actually change. It doesn't lose the color. Why is that? Oh, shit, wait, hold on. Is it because when we invalidate the style, then it is currently the hovered node, even though it's about to not be the hovered node. So, right, so the style invalidation actually ends up looking at this pointer here that we're messing with. So we have to avoid that. So let's say, let's do it like this. Old hovered node. And then we'll do that afterwards. Oh, look at it go. That's so cool. I'm just waiting a little bit here because I know it can be a bit crashy if I move the mouse too much while it's doing stuff. Okay, so now these are all invalidating style. And we can see that the CPU meter up here is definitely noticing us mousing around. And style invalidation could be a lot better. Could be a lot less CPU heavy, but it still works, and it is very snappy if I actually do change one of these. Very cool. All right. I wonder why it's using all that CPU though. Like, are we actually triggering repaints? Because we shouldn't be. But maybe it's just running all the selectors and everything. Maybe that's what's heavy. I don't quite know what's heavy, so let's see. When we invalidate style, we recompute style for all ancestors. But if the difference is none, so let's say debug, style actually changed. Because this is the one I want to see, like if it actually changes for anything. Then I can understand that some heavy stuff would have to happen. Oh shit. Okay, well, we don't need to go to the website. Style actually changed, right? But then if I'm just mousing around, nothing bad. And yeah, none of these have any hover things. But even so, when I'm mousing around, it still does invalidate style. So, you know, we could do this a lot better. We could like, we could have bits cached on elements, for instance, that would remember if this element would be affected by the hover state changing, things like that. But right now, I'm not going to do that now, but I'm still happy that I went and I did this partial invalidation so that we can notice when when style change requires repaint. So let's take a look at what we've done in a patch review. So first off, we added the style properties comparison operator, which just compares two sets of style properties, basically. Probably this is why it's so chunky, because we're just doing this fugly map comparison by iterating one and then looking up in the other, and then serializing each entry and doing a string compare. There are definitely more efficient ways to compare two sets of style properties. Anyway, and then in the DOM document, when we change the hovered node, then we stash away the old hovered node, and then after we actually change the hovered node, we call invalidate style on both the old and the new hovered node. Cool. And then in element, we now have this mechanism called recompute style, but let's see where that's called first. So that's in node invalidate style. Right. So when you call node invalidate style, it walks all of its ancestors, and for each element, ancestor calls recompute style. And then what that does is that it grabs the parent layout node and takes the style from him, passes it in as the parent style to the style resolver, and resolves a new set of style properties for this element. And this is where the selector engine gets to run again and everything, and it will actually match the hover selector differently this time in case this element is now hovered or no longer hovered. Okay, and then after we compute the new style, then we compare the old style and the new style, which is what we do here. And this function here tells us, well, how much of a difference is there? Like, is there like effectively no difference? Or do you need to repaint because of the difference? Or do you need to relay out because of the difference? And then this is a really kind of an ugly way of only doing parts of it, but Rome was not built in a day, right? So I think that the general idea here is kind of sound. It just, we don't have just the right data structures for everything yet, but things will fall into place, so don't worry. Right, so we compare like if the color property is different between the new style and the old style, then we say we do need to repaint. Or if the background color is different, then we also need to repaint. And I'm not going to bother with needing a relayout right now because that will take a lot more work. But I think this is pretty cool. And then if we do learn that the style difference requires us to do a repaint, then we call setNeedsDisplay on our layout node, which effectively invalidates it. Like it tells the Windows server, hey, you're going to need to repaint whatever is in this rect here. And because we've called setStyle on the layout node, then the next time we paint the layout node, it's going to look different. And that's it. So that's pretty cool. Implement basic partial style invalidation. This patch makes it possible to call a node validate style and have that node and all of its ancestors recompute all of its element ancestors. Actually, this makes me realize that if this node is an element, then we should also call recompute style on it. So we'll do this, and here we'll just say node, because it's not an ancestor of itself, so we'll just do that. If you're an element, you'll also recompute the style, because sometimes you're hovering over an element. So I want to amend to that. Okay. And have that node and all of its element ancestors have that node. All of its, I mean, we don't need to go into the detail about the element part here, but all of its ancestors recompute their style. If the new style is visually different from the old style, we then figure out if the new style is visually different from the old style, and if so, do a paint invalidation via setNeedsDisplay. Note that the is visually different code. Are they visually different code is very not finished. Very not complete, let's say. Very incomplete. Can I fit one of those? I couldn't. Well, I guess we don't get a cute smiley face there. But that's really cool. And then let's say use this to make hover effects a lot more efficient. They now no longer cause a full relayout plus repaint, but only a style invalidation. Style invalidations are still quite heavy though. There's a lot of room for improvement. There. Aha, finally. Some space for my smiley face. Boom. That's pretty cool. So let's see that one more time. Oh, crap. Style actually changed. I didn't want that message sitting there. Oh, maybe I just forgot to do a rebuild. I'm going to need some better data structures, that's for sure. But it is so cool that you can, that this works. I love it. Yeah, that CPU thing is bothering me. I'm going to have to work on that. But at least I got to where I wanted to get with this patch. And I almost tried to avoid having to work on the style invalidation stuff, but I'm glad that I actually took the time to start working on that, because that's going to be an important part of libHTML engine performance going forward. Because like layout engine performance in a web engine is like extremely dependent on how good you are at invalidating style. So it's good to get started on that. Look how cool it looks when it just relayouts so quickly. This is just too much fun. I'm having so much fun since I've been working on this now. So I should really say a double thank you to Sergey, because after he implemented the text rendering, then I was just filled with motivation to work on this again. I don't know what it was, but something about that text rendering just made it so much fun. So I guess this is going to be it for today's video. So if you made it this far, then I thank you for watching and for hanging out with me while I implement these things that you're not supposed to be able to implement by yourself, they say. These silly people who think that you cannot build big things. So yeah, let's just continue not listening to them and seeing what else we can build here. And I hope that you have a great day, and I hope that your projects are going well and that everything is cool. So thanks for hanging out. I'll see you next time. Bye.